Hello, I'm Patty Simpson with Simpson Math. In this lecture, we're going to learn some statistical vocabulary. Throughout the entire semester, we're going to be using this same vocabulary, so we kind of all need to be on the same page and understand these words going into the semester. So, first of all, here in stats, our main goal is to answer questions. So we have some broad question that we want answered. And what we do is we go out and we collect data, we describe that data, we analyze that data to help us to answer our question. That's kind of the overarching goal for what statistics is. And so when we do that, when we ask some question, we have some group in mind that we're asking a question about. So for instance, let me give you a couple of examples. Maybe I want to know about you guys. I want to know how successful are my students going to be this semester. And so that's my question in mind. And so I go out and I collect some data from you. I ask you questions like, how many hours a week are you working outside of class at a job? How many kids do you have at home? Do you have other responsibilities like parents you have to take care of, or I don't know, animals in the house, or what other responsibilities do you have outside of class that are going to keep you not focused on me? So I ask you these questions, and then I collect this data and I look at that data and analyze it to help me answer that question. Okay, so there's an example of it. Or maybe I have an orchard of pecan trees and I want to know how many pecans is each tree dropping? You know, on average, what is the number of pecans that my pecan trees drop? So I have some question and I use my data to help me answer the question. Well, the first vocabulary word we need in order to talk about these things is a population. So we want to know what is our population. And the population is just the entire group of interest. Our entire group of interest. That's what a population is. It's the group that we're interested in, and it's that whole group. So for instance, when I'm trying to find out about my students, is my group of interest just my statistics students? And if so, then my population would be all my statistics students. Or maybe I don't care about those face-to-face students. Maybe I only care about my online statistics students. Well, if those are the ones that I'm interested in, then maybe my group of interest, my population then would be my online statistics students. Maybe I care about all of my students, my college algebra students, my contemporary students, my math for business and social sciences students, maybe all of my students. Well, in that case, my population is all of my students. So it kind of depends on what the group is that I'm interested in. That's number one for the population. And it's that whole group, that entire group. When you talk to me about your population, when I ask what is the population, you should always include words like entire, or all, or whole, the whole group, or every. Words that are letting me know that you're talking about every one of those members. So like with the pecan trees, I'm not just talking about some of my pecan trees. I want all the pecan trees in my orchard. Or maybe I'm interested in the pecan trees all in the state of Texas. Well, then all of a sudden my population is all pecan trees in the state of Texas. Or maybe I just want to know the average number of pecans dropped by a pecan tree in the world. Well, then my group of interest is all pecan trees across the world. So the population is the entire group that you're interested in. Okay, we're going to compare that word to, by the way, if we can, our goal is to be able to collect data from that. So I said that earlier, than maybe if I'm collecting data on my students. I go out and ask every one of you, how many hours outside of class are you working? How many kids do you have at home? What are your other responsibilities? If I collect data from all of my population, maybe before I do that, let's define this word data that I keep using. What do I mean by data? Data is just a measurement or a count or an observation. That's all data is. It's just some sort of measurement or count or observation. In other words, you're telling me how many hours a week you're working outside of class. That's a measurement. You're telling me the number of hours. Or maybe you're counting how many kids you have at home. Or you're observing the other responsibilities. You have parents you have to take care of. So that's all data is a measurement, a count, or some sort of observation. And then if you are able to collect data from your entire group, we call that a census. So a census is a study where data is collected from the entire group. From the entire population. So when we collect data from the entire population, we call that a census. Now, the year right now is 2020, and the government is attempting to do a census right now. They're sending out information to all of the households across the United States, and they'd like to get data from every single person in the United States. And in fact, if you don't go online and fill out the little form giving them their information, they're going to send people knocking on the doors of houses to get information from you. So they're attempting to collect data from the entire population. Do you think they're actually going to get data from everybody across the United States? That's probably not going to happen, right? That's hard. To get data from your entire population is hard. And a lot of times, even when I survey something like everybody in my class, somebody will be absent. Or I'll send it out to the online students and not everybody will answer. So even when your population is small, sometimes it's really hard to get a census, data from the entire population. But that's what a census is when we're trying to collect, or when we actually do collect data from the entire population, we call that a census. But most of the time, we can't actually get a census. Most of the time, we can't actually get data from our whole population. So instead, we just collect from part of the population, and we call that a sample. So a sample is just a subset, which just means part, of the population. That data is collected from. So a sample is just part of that population that we are actually able to collect our data from. So most of the time we cannot get a census. We'd love to be able to. Getting data from the whole population is like the most accurate. That's the best thing to do. But trying to get data from your entire population is hard. It sometimes takes time. It takes money if you're doing different types of studies. It takes manpower to go out and, count pecans underneath the tree from every one of the trees. So because it's so time consuming and it costs so much money, most of the time we can't actually get a census. So what we do instead is we just collect from a sample. I send out the survey and hope that I get people online to answer it. Or I do it in class and hope that all my students are there. And I just ask the ones who happen to be in class that day. So to get my data back from. Maybe I could follow up in my classroom because it's a small enough population so I could eventually get a whole census. But even within the classroom, sometimes that's hard. So our sample is just that. It's part of our part of the population. Now, let's just look at this example here and see if we can find our population and our sample from this situation. So here we have Southwest Elementary wants to know the average number of homework assignments completed by their students throughout the school year. 700 students are enrolled in the school. 5 students from each grade level, pre-K through 5th, are selected. The 35 selected students are asked to record the number of homework assignments completed. So first, what is our population here? What is that entire group of interest? Well, Southwest Elementary only is interested in their students. So the population here, the population, the group that they're interested in, population is all or every student at their school. They don't care about Jefferson Elementary. They don't care about the students at Miller Heights Elementary. They only care about the students at their school. But they are interested in all the students at their school. So the population is every student at Southwest Elementary. So that's our population. That is our group of interest. And notice that I used this word every in there. Or I could have said all the students there at Southwest Elementary. So that is our group of interest. Then notice that we do know the samples, the population size. In other words, we know how many people are actually at their school. The population size here is 700 students. That population size, every student there at the elementary is the population, and the population size is 700. Now, in the future, I'm going to use a capital N. So I'm going to use a capital N to tell me about the population size. I'm going to use this notation. I'm going to use that word notation throughout the semester. It just means the way we write things. So we use a capital N to tell us, that's like our variable we use to talk about the population size. So I could just say here that N equals 700. Our population size is equal to 700. Now, we weren't able to collect data from the entire population. In other words, they didn't ask all 700 of their students to write down how many homework assignments they collected, or the teachers to write down all of the homework from all of their students. Instead, they just chose 5 from each grade level, or a total of 35 students to collect data from. Those 35 students where data was collected from, that makes up the sample of the population. So the sample in this case, the sample is the 35 students, that data was collected from. So those 35 students that recorded their data, those make up the sample of the entire population. So we could say that the sample size then is 35. There are 35 students in our sample. So the sample are the students that we collected data from, and then the sample size in this case is 35. Just like we denote our population size with a capital N, we're going to denote our sample size with a lowercase n. So that lowercase n is equal to the sample size. So in this case, I could just say lowercase n equals 35. So population is your entire group of interest, and the sample is just who you, out of that population, who did we actually collect data from. Notice that my population are the students at Southwest Elementary, and my sample are also students at Southwest Elementary. It's just, this is part of that. So your sample should always be a part of your population. Okay, so those are two important words that we're going to use over and over again throughout the semester. And we need to know that that capital N refers to our population size, and the lowercase n refers to the sample size. Let's talk about some other words that we're going to need to know this semester. I used the word variable when I wrote that capital N. Let's talk about this word variable. And what do I mean by the variable in a statistical study? So a variable is just a thing that changes. A variable changes. So, maybe you're used to a variable being a letter. Like I said, n was our variable because the population size is going to change from population to population to population. For each study, our population size is going to change. So that capital N, maybe you think of as being a variable. Or maybe if you've done some algebra, you think of your variable as being x. Because we're solving for x, and each time we come up with a solution for x, it's different, it changes. In statistics, when we're talking about the variable in a scenario, we're talking about what changes between members of the population. Or you can also think of it as the thing that we're collecting data about. What is it that we want data on? What are the measurements? What is it we're measuring? What is it we're counting? What is it we're observing? So when we're talking about the variable, it's that data that we're collecting. What is it that's changing or varying from member of the population to member of the population? So in this case, when I look at the variable of this scenario, what is that thing that's going to change from student to student? What is the data that we are collecting? So notice that the data we're collecting here is the number of homework assignments completed. That's what they're recording. There may be other variables, like maybe whether or not they're boys or girls. That's a variable about the students. Another variable it says in here is what grade they're in. But that's not the data we're recording. The data we're actually looking at and we're paying attention to, the variable of interest here, is the number of homework assignments completed. So that is our variable of interest. The number of homework assignments completed is the variable. That's the thing that's changing from student to student, and it's the thing that we're collecting data about. So we have population, we have our sample, we have data, just a measurement, a count, an observation. We have our census, is when we're able to collect from the entire population. Then, last but not least, let's talk about the word statistics and parameter. So let me talk to you about this word statistic. So there are two definitions of statistics. You're in a statistics class. When I talk about statistics generally, or a broad view of statistics, when I'm talking about that broad view, I'm talking about the science of collecting, describing, and analyzing data. So this is that idea that we have some question and we go out to answer our question. We're going to collect, describe, and analyze that data. So when I talk about you're taking a statistics class, this is what I'm talking about, that broad view of what it means to be statistics. But there's a more specific meaning for statistics within the class and within the world. When you also hear a statistic, your second definition for statistic, that you hear this word used a lot, is just one number that summarizes the data. One number or one numerical value that summarizes your data. So what do I mean by that? Well, think about your grades. You know, throughout the semester, you get a whole bunch of different grades. You know, on one test, you make a 70, on another test, you make 100, on another test, you make a 94, on another test, you make a 90, and then at the end of the semester, we say that your grade overall is an 84. We narrow all those grades down to one grade, and that one grade describes how you did in the class. That one number is a statistic if it's collected from a sample. So one number that summarizes the data collected, this is a big deal, collected from a sample. So if it's collected from a sample, then we say that it's a statistic. In your grades class case, though, you have all the grades for that particular class. So you are actually able to, your group of interest then, or all the grades in your class, you're actually able to collect all of those. And so therefore, a parameter is one number that summarizes or describes the data collected from a population. So collected in a census. So in other words, from the whole population. From the whole population. So notice these things are both the same thing. They're both one number that describes or summarizes data. It's just that we use this word statistic when we've collected our data from a sample, and we use the word parameter if we were actually able to gather a census, if we were actually able to gather data from our entire population, then we call it a parameter. So a lot of times you hear about statistics. They'll say the statistics, you know, every day 100 people die on the roads. Well, the minute we say, you know, an average of 100 people die on the roads, we narrow it down to that one number. That's a statistic. We're looking at a sample to see what that statistic is. Or they say, you know, 40% of the population do blah. Well, that percent, we've narrowed all of our data down to one number. And if we've collected it from a sample, which most of the time we do, because getting information from a whole population is hard. So since we're collecting most of the time from a sample, we're usually getting a statistic. So that's why you hear the word statistic out in the real world all the time. And all a statistic is when you've gathered a bunch of data and you narrow it down to one number. So things, different statistics or parameters that we're going to learn about this semester. Some different examples, like I said, your average in a class. We call that the mean. But all averages, medians, and modes, which we'll learn about later in the semester, all averages, once you take all your data and find that average, that's an example of a statistic or a parameter. We're also going to learn about some other statistics. or parameters. The standard deviation is another one we're going to learn about throughout the semester. We're going to learn about something called the variance, the mean absolute deviation. We'll also learn about percents or proportions. All of those are examples of statistics where we take a whole bunch of data and just say, well, you know, I've got all this data, and then I just narrow it down to one number. Then that one number, if I collected my data from a sample, is called a statistic. If I was actually able to collect a census, then it's called a parameter. Okay, so let's look at our example again and see if we have a statistic in here that we can see. Maybe we don't. Or if we have a parameter, or which we would be collecting. Let's just look and see. So on this, they wanted to know the average number of homework assignments. Notice that their variable, though, were the number of homework assignments completed. So they collected from these 35 people a bunch of homework assignments. So, you know, maybe one of them did 100 homework assignments, and another one did 200, and another one did 150, and another one did, I don't know, 120. Well, at the end, if they add all those up and divide and say, well, on average, our students do 115 homework assignments throughout the year. Well, that 115 is one number that describes all their data. Their data was collected from a sample. So that one number, that average, would represent a statistic. So the average that they're looking for, the average is a statistic because it is one number. The statistic because it is one number that represents all the data collected from the sample. So it's a statistic because it came from a sample. Statistic and sample, whereas parameter comes from the population, if we're able to gather data from the whole population. So those are kind of the words that we're looking at, and we're going to be using these throughout the entire semester. Population, your entire group of interest. Sample, just what part were we actually able to collect data from. Census, if we're able to collect data from the whole population. The variable, what is it that we're looking at? What changes? What data are we collecting? What changes from member to member? And then the statistic is one number that represents all the data from a sample, and the parameter is all the data collected from a population. One number that represents all that data from a population. Okay, we're going to do a couple of examples of things that you might do tonight in your homework, where you're just going to talk to me about those vocabulary. So let me bring in these examples here. And we'll just do these couple of examples to talk about the population, the sample, if there is one, the variable. So here's a couple of different studies. Let me erase this, and then we'll write some sentences up here. And in your homework, you're going to run or write sentences. Let me know, that first of all, part of statistics is being able to communicate about that data that you've collected. So we're going to kind of get in the habit of writing sentences and about our information. So as you answer your homework tonight, you're going to want to make sure that you're writing in sentences. And then you're justifying your answers, like why are you answering the way you're answering? So here's an example. Bluebell Creamery wants to determine its customers' favorite ice cream flavor in the state of Texas. The company sends out surveys to random customers. 2,250 customers completed the survey. 30% said milk chocolate. was their favorite. All right, so we're going to answer these questions. We're going to find out what the population is. We're going to tell what the, if there is a sample, what the sample is. We're going to see what the variable is. What are we collecting data on? What changes from person to person or thing to thing? And then we're going to determine if there's a statistic or parameter collected. And if so, can we actually find it? All right, so the population in here, what is our entire group of interest? Who is that entire group of interest? Well, in this case, Bluebell Creamery wants to determine its customers' favorite ice cream flavor. And we only care about the ones in the state of Texas. So the customers are their group of interest. Their customers are their group of interest. That's who they care about. And they only care about Bluebell customers, and they only care about the ones in Texas. They don't care about the ones in Florida. They're not talking about the ones in Oklahoma. It's only the ones in Texas. So the population here is, remember, we need to use one of those words, all, every, whole, entire. So the population is every customer, every Bluebell customer in the state of Texas. Now, we don't know what that population size is. How big is that group of interest? I don't know how many customers there are in the state of Texas. It doesn't tell me in this scenario. In fact, Bluebell might not even know the total number of customers, because I might be a customer today and not one tomorrow. Or I might, who are they counting as customers? Is it a customer if I bought one thing of ice cream ever in my whole life, or do I have to buy one every week? Or, what makes up a customer? So I don't know what that population size is. So I can't tell you what our capital N is. But here, the sample, were we able to collect data from that entire population? Well, again, I don't even know what the population size is. And in this case, we weren't able to get information from all of their customers. So unless they narrowed that down to say, just the customers that buy Bluebell at this store at this time or something, being able to get information from their whole population would just be almost impossible, would be impossible. So instead, what they do is they just get information from part of their group. They didn't collect a census, they just got it from part of their population. So the sample here are the customers that completed the survey. The ones that data was actually gathered on. The sample is the customers that completed the survey. They're the ones that actually gave us information. We got data from those. Now notice that our population is customers and our sample is customers. These two things are the same thing. These are just part of our whole. We can tell us the sample size. We do know the sample size here. We know that the sample size, or our little n, is equal to 2,250 because there were 2,250 customers that completed that survey. We got data back from 2,250 customers. Then what is our variable? What is it that we're collecting data on? What changes from our customer to customer? Well, we're collecting data on their favorite ice cream flavor. They're writing down their favorite ice cream flavor. So maybe I say mine is mint chocolate chip, and maybe you say yours is cookie dough or brownie bits. So the favorite flavor of ice cream is the thing that varies from customer to customer. So the variable is the favorite or the ice cream flavor. That's what each customer's writing down, is their ice cream flavor. Then we want to ask ourselves, did we collect a statistic? Once we've collected our data, you write down cookie dough, I write down mint chocolate chip. That person writes down brownie bits, somebody else writes down milk chocolate, somebody else writes down vanilla. We have another milk chocolate. We look at all that information, all of our data, and we narrow it down to one number, one numerical value, and that one numerical value, is it a statistic or a parameter? Well, since we collected data from a sample, it's going to be a statistic. Then, what is that one number that we narrowed our data down to? Right here, that 30% is the one number that we've narrowed all of our data down to. That 30% is a statistic. 30% is one number that describes our data. And our data was collected from a sample. So that 30% is one number that describes data that was collected from a sample. So that 30% is a statistic. So 30% is one number that describes all our data we collected. We collected that data from a sample, so we call that a statistic. 30% is a statistic in this case. Just for fun, and because we can, and because we've been working on percents, I want to know if 2,250 people, customers, turned in their survey, and 30% of them said milk chocolate, how many customers said milk chocolate? So here's my question. How many people, how many customers that completed the survey with milk chocolate? How many customers completed survey with milk chocolate? Can you figure that out? Think about how to find the percent. I bet you've already got it figured out. So we're really asking 30% of 2,250. And know from previous lectures, from previous videos, that we've done just that. We've done 30% of the 2,250. Remember, all we do is multiply. So maybe you multiply 0.30 times 2,250, or maybe you say that 30%, which is just 30 over 100, remember percent is always over 100, times 2,250. I'm going to go ahead and reduce this 30 and that 100. 30% could just be written as 3/10, because if you simplify your fraction, you just get 3/10. I'm going to go ahead and remember you multiply straight across with your fractions. But that means this one's going to be on top and this 10 is going to be on bottom. So I can go ahead and divide 2,250 by the 10, and that 0 and that 0 is going to go away. So I'm just left with 3 times 225. Well, I know 3 times 25 gives me 75, and 3 times 2 gives me 6. So that tells me that 675 people answered with milk chocolate. So knowing that 30% of the sample said milk chocolate, I can tell you that 675 of them of 675 pieces of data said milk chocolate. That's what the people said. Now, I could also do something like if I knew my population was bigger than that, maybe I have 10,000 cells within the month or something, I could predict how many people would be buying milk chocolate. That 30% would help me to make that prediction. So that's how the statistics works. So we found population, sample, variable, and we determined that that was a statistic. Let's do this one more example here. A mental hospital wants to find out what percent of their patients admitted have depression. They checked the records of every patient admitted in 2016. Out of the 40,000 patients, 32,000 had been diagnosed with either situational or clinical depression. Okay, we're going to do these same things where we're looking for the population, the sample, the variable, and then we're going to see if there is a was a statistic or a parameter there that we've collected. So you can pause this for a second and see if you could answer that on your own, and then check with me. So see if you can write those down and then check with me. Pause it for a minute. And I'm going to go ahead and do this. So the population is, well, that's our entire group of interest. And what is their entire group of interest? Well, they're interested in their patients that are admitted to the hospital. So the ones who are, outpatients, those aren't the ones we're looking at. We're not looking at the ones that just come in and leave. We want to know about the ones that are admitted to the hospital. And we don't care about the patients that are admitted to Scott and White. We only want to know about the patients at this particular hospital. So the population is all, did you write down a word like all or whole or every or entire? All the patients from their hospital that were admitted. That's the population. That's the group of interest there. Then what's the sample? Well, the sample's the ones that we collected data from. By the way, we don't know how many total patients there were, because this doesn't limit it to a certain year. It doesn't say in 2016. It doesn't say in 2014. It's just all their patients, like over time. So we don't know how many patients they've had. We don't know that population size. Then the sample is just the ones that we collected data from, the patients the data was collected from. So the sample is the patients data was collected from. In this case, it's all the patients from 2016. So all 2016 patients. And we do know that there were 40,000. So our sample size here is 40,000. That's our sample size. So it's all the ones that we collected data from. In this case, it's all those from 2016. And it's the 40,000 is our sample size. Then what's our variable? What is it we're collecting data about? What is it we're interested in? What changes from patient to patient? Well, here is what their diagnosis is. Are they diagnosed with depression or not? So what varies? They're looking each time, they're writing down each time the diagnosis. What's the variable? Well, it's the diagnosis of each patient. That's the variable, the thing that's changing from person to person. Then, once I've collected all my data and I get one number from it, because that was a sample, because we collected a sample, that one number is going to be a statistic. In this case, we can make a percent or a proportion for that number. So like the 32,000 out of 40,000 is a proportion. That's one number, or we can turn it into a percent. You know, we know to turn that into a percent, we would reduce that by 100. So I have 320 out of 400. But remember, to make it into a percent, I want my denominator to be 100. So I'm going to divide my top and my bottom by 4 to get down to 100. Divide the bottom by 4 and you get down to 100. Divide the top by 4. Well, 32 divided by 4 is 8. 0 divided by 4 is 0. So this is 80%. That proportion, 32,000 over 40,000, or 80%, is one number that describes the data. And this data was collected from a sample. Describes data collected from a sample. So therefore, this is, so 80% is a statistic. Okay, I'm going to make one little change to this scenario. One little thing that I'm going to change for my scenario, and then we're going to go back and look at the population, sample, variable, and statistic, and see if any of that changes. So here's what I'm going to do to change it. I'm just going to take, and I'm going to say that this mental hospital wants to find out what percent of patients admitted in 2016 had depression. So which one of their their patients, or how many, what percent of their patients in 2016 had depression? Now all of a sudden my population has changed just a little bit. I no longer am interested in all the patients that I've ever had and ever will have. I'm now only interested in the population of all the patients from their hospital that were admitted in 2016. Those are the only ones that we care about now. So it just changes my population just a little bit. Instead of being interested in all our patients from all time, we're just interested in the patients from 2016. There's my kitty wanting in. Then, we no longer have collected a sample. We were actually able to get the records of every patient admitted in 2016. So, this is no longer a sample. We actually collected a census. So, in this case, instead of being a sample, it's now a census was collected. A census was collected. So all patients' data was collected. All 2016 patients. So that means that a census rather than a sample was collected. And it's no longer my sample size was 40,000, but now all of a sudden my entire population size was 40,000. So just changing that one little group of interest, instead of being my population, census, sorry about that, instead of looking at a sample, I've now collected data from my entire population. Then the variable doesn't change. I'm still writing down the diagnosis of each one of my patients. That's still the thing that changed from patient to patient. And now that I've collected an entire census, I got data from the whole population. this 80% is no longer a statistic because the data was collected from a census. It was collected from all the population. So now that 80% describes data collected from a census or all the population, then that 80% is called a parameter. So see how changing my group of interest there changed the census, and it changed my population. It changed the fact that I had instead of a sample, I now have a census, and then it made this a parameter rather than a statistic. So being able to understand whether or not we have a sample or a census, what is our population, what is that group of interest, who are we collecting data from, what are we collecting data on, all those things are really important. And being able to use those words, population, sample, variable, census, data, parameter, and statistic, are going to be really important throughout this semester. All right, your job is to go do that homework, and I'll be around to help. So be sure and ask me questions. Math Made Simple, it's some math. Thanks for watching.